What's happening, dogs? Mr. Allen here with some graphing of trig functions, and we're getting a little more complex here with these ones. We got a whole bunch of transformations, so a lot to unpack here. Let's get it popping. All right, so we got y equals -3 sine of 2 theta minus pi over 2, and then on the outside plus 1. Well, I can't really fully analyze this thing and get everything done until I factor the inside here. We always take out that coefficient of theta if there is one, and it's not in that factored form. So everything else, no big deal, but we got to take care of that. So -3 sine, then we'll have 2 parentheses theta. What's pi over 2 divided by 2? Sometimes it's a little bit confusing, okay? You're dividing by 2, or you could think of it as, okay, well, if I multiplied back in by 2, how would I get to my original pi over 2? It's going to be pi over 4, okay? So pi over 4, close them, plus 1. So let's talk about that one more time there. You can either think of it as pi over 2 divided by 2, that becomes pi over 4, okay? Or we can think, well, if I multiplied 2 to pi over 4, I'd have 2 pi over 4, which simplifies to pi over 2. So just make sure when you multiply that back in, you'd get back to the original so you didn't make some kind of a silly error, right at the start of this problem, and then things are all screwed up, all right? So the only thing that affects is our phase shift, but you can't see the phase shift unless it's in that factored form. So make sure you do that. All right, now, period of this thing, period of this function. Well, our period is 2 pi divided by b. b is my value right there. So I'm going to take 2 pi divided by b, which is 2. Those cancel, and I'm left with pi for my period. How about my amplitude? Well, that's going to be 3 out there. It's not -3, it's just 3. It's how much I'm oscillating above and below that midline, which, why don't we just talk about the midline now? I'll jump to the end. I don't care, right? Plus 1. So we got y equals 1. And I'm just going to plot that right now, okay? Whee! Beautiful. How about our phase shift? Well, we did the factoring so that we could identify our phase shift, which is to the right pi over 4. So on the inside, remember, it's opposite of the sign. It's going to move to the right pi over 4 rather than to the left. All right, so right pi over 4. And we'll do our domain and range at the very end as long as I remember. Sometimes I forget to do that later on. Oops. All right, hopefully I don't lose any points. All right, so let's see here. Do we need to scale this thing differently? Yes, okay? So a lot of times I'll say, like, scale. I'm going to take that pi, my period, and I'm going to divide it by 4, which is just pi over 4. All right, there we go. So I'm scaling by pi over 4s. So we get 1 pi over 4. Here's going to be 2 pi over 4, which simplifies to pi over 2. This would be 3 pi over 4, which cannot be simplified. Here I'm going to get 4 pi over 4, which is just pi. And look at that. There's our period, right? There's going to be a shift here, so it's not going to be right there. But that's one period of this. We can even do 5 pi over 4. Here I'd have negative pi over 4, and this would be -2 pi over 4, so negative pi over 2. Might not use it all, but we've got it if we need it. All right. Next up, let's see here. We'll just go by ones here on our scale on up. 1, 2, 3, and 4. Here's going to be -1, -2, -3, and -4. All right, there we go. So a lot of times with these trig graphs, most teachers will leave it up to the student to scale it, because although you can see the horizontal stretches and compressions a lot easier if you have a standard scale, these things can get pretty out of hand pretty quick, so it's usually just easier to scale it appropriately. And then the graphs all kind of look the same, which is a little lame, but it is what it is. You pick your poison. All right. So let's see here. Can we start graphing this thing? I think so. But we got to be careful of our phase shift and where we're going after our initial point. So my phase shift, we said, was to the right pi over 4. My sine graph always starts on the midline, would normally be at the origin, but it's up here now, right? And I move to the right pi over 4. So this is going to be my first point of this sine graph. Now, we have an amplitude of 3, right? And we have that negative right there, so it's a vertical reflection. I'm going to start by going down from the midline for my first point here. So I'm going to go down, but it's down 3, and don't screw that up, okay, and accidentally go to -3. We'd be at -2 for this thing. And now that I'm below the midline, I got to come back up to it. And now that I'm on the midline, I got to go above it all the way up to 4. Hopefully I'm not off the screen there. I know it's pretty close. And then back down to the midline. So this right here is 1 period. So I'll go ahead and connect my lovely dots here. Whee! Sound effects Optional, but in my opinion, necessary. Okay, but optional if you don't want it. So there we go. There's our full sine graph there. If we wanted, we could, continue it on back the other way. I got a lot going on here. I'm going to leave this one as is. Cool. Awesome. Fantastic. Almost forgot our wonderful domain and range. Domain, all real numbers for these sine and cosine functions. So theta equals all reals. And then my range, I'm going between -2 and +4 for this one. I'll use interval notation, -2 to +4. You could do inequalities. It'd be -2 is less than or equal to y is less than or equal to 4. I prefer interval notation in certain scenarios. I prefer set builder notation in other scenarios. It just kind of depends. This seems like the cleanest option, so I'm going to go with it because it's my video. All right, there we go. Lovely. Awesome. Fantastic. Can you guys hear that train? They're honking their horn. All right. And if you can't hear it, you'll be like, what? What are you talking about, dude? All right, let's graph this cosine one here. Man, that first one was a beast. Let's see what we got here. Lovely. It's already in factored form. That is fantastic here. That's good news. We don't have to rewrite this thing. So how about our period? Well, 2 pi divided by pi. The pi's cancel. Our period is 2. So our scale is going to be 2 divided by 4, which is 1/2. So we're going to be going by 1/2, right? I always take my period, I divide it by 4 to get my scale. So we got 1/2, 2/2, which is 1, 3/2, 4/2, which is 2. It's kind of just like pi over 2, pi, 3 pi over 2, and 2, just without the pi's, right? And I'd have -1/2 here and -1 right here. I could even go to, whatever. All right. We could do. We don't need to. It's fine. It's whatever. It's whatever. All right. Let's continue. So now, let's see. I'll go by 1 because I see this is going to be moving up 2, and it has an amplitude of 2 here out in front, right? I do have a phase shift. We got a phase shift of going left 1. So left 1. Our midline is y equals 2, right? So we moved it up 2. So let's dash that in right here. And as I was saying, we'll go by 1, 2, 3, and 4. -1, -2, -3, -4. Okay, cool. Let's change colors here for the actual graph so it stands out. It's popping. I'm going to go with pink again for this one because I feel like that's going to look pretty dope. All right. So our cosine graph starts above the midline, which is at y equals 2 for this one. So I'm going to start above the midline, but we have to shift. Which way do we say? Left 1. So we're actually going to start, unfortunately, right in the function right here. Poor planning. There it is. There's our first point. All right. And then, let's see here. We got, we're going to go to the midline. So we're going to be right here. Then we're going to be below the midline by 2, which will be right here. Then we'll be on the midline at our next point. And then up here at 4 for the next one. All right. There we go. I should have done a -1 so we could have been over here. But hey, whatever. It is what it is, man. Cool. So that's one full period, right? From -1 to +1 is 2. And that's what my period is. That makes sense. So when we connect these dots here, remember we got to be thinking about how it's going to be going back down there. And some nice curvature to it. Going to be coming back down. There we go. So always, always, always make sure that your cosine arrows point back down or back up if this thing is all flipped. All right, whereas your sine ones can pass through because it's going to be going up to the next point up there. Whereas these are coming back down to some point that exists right here, another one that exists right here, and that's where that trajectory of that graph is then going to be going, okay? So think about those things. Those are easy half points to miss when you're graphing trig, and you will most certainly get a half point off, all right? Otherwise, I got beef with that teacher because they should not be pointing up. They should be coming back down. All right, there we go. Ooh, wait, domain and range. Almost forgot. So our domain here, again, all real numbers, so theta equals all reals. And then my range, how high up, how far down? Well, I'm going to be going up to +4, down to 0, so we're going to be between 0 and 4. Excellent. Fantastic, wonderful, and awesome. Thanks for hanging in there, guys. I think we're going to get some reciprocals going here soon, some tangent and cotangent as well, and then maybe even writing some equations given a graph. That's always fun. So stay tuned, keep watching, and stay dope.